Welcome back to the deep dive. I'm really glad you're here with us today because we are looking at a stack of research that is, frankly, it's a little unnerving.
Oh, absolutely. Unnerving is, that's the right word for it.
Yeah, and I don't say that lightly. You know how sometimes you look at the stock market or just the general tech landscape and it feels,
It just feels weird.
yes,
Yeah.
weird, like not just your standard up and down weird, but more like,
Like the rules of physics are changing weird.
exactly.
It feels like the tectonic plates are shifting right under our feet while we're just, trying to drink our coffee and go to work. We're seeing patterns that completely defy the old models.
Right, and that is exactly where our sources start today. They paint this incredibly vivid picture of the current moment. They ask you to visualize the logos of these massive Silicon Valley companies.
Specifically the SaaS companies.
Yeah, the service as a software guys, you know the ones. The absolute darlings of the last decade.
The companies that built the literal skyscrapers in San Francisco.
Right, the ones that could do no wrong. But the source describes their logos turning red. It describes their stock charts just nosediving.
It's like watching a glamorous, supposedly invincible city start to crumble into the ocean.
It really is. And the mission for this deep dive is to figure out why. Because the source identifies a very specific culprit for this bloodbath.
It does. And it's the elephant in every single room right now. Generative AI.
Generative AI.
But it's not just the buzzword. The source digs into the specific mechanical function of what AI is doing to the fundamental value of software.
And it's not just that old narrative of, oh, AI is coming for our jobs. The argument here is much more specific and, honestly, much bigger.
Much bigger.
The source argues that we are moving from one completely distinct era of human technology,
The software era.
right, into something totally new, what they call the physical AI era.
That's the key phrase you need to keep in mind. Physical AI.
Yeah.
We spent 20 years living in the software era.
Since the dot-com boom, really.
Yeah. Since then, value was created entirely on screens. It was digital. It was pixels. It was code.
And it made a lot of people very rich.
It did. But the argument now is that the digital world is tapped out. The next massive tranche of value.
We're talking trillions of dollars of value.
Trillions. It is not going to come from another app. It's going to come from AI that actually has hands and feet.
Hands and feet. That is such a wild image to me. And that leads to the really provocative claim in this research.
The destroyer claim.
Yes. It argues that most of the tech companies we know and love, the ones that basically built the modern internet, are about to be destroyed.
Destroyed.
Yeah.
And there is one specific player, Tesla, that is positioned to be the destroyer.
The destroyer. Because they are mastering the physical world.
Exactly. It's a destroyer versus destroyed scenario. I know it sounds dramatic.
It sounds like a sci-fi movie.
It does. But when you peel back the layers of the economic argument the source lays out, it's actually incredibly logical.
So here is the big question we need to answer for you, the listener, over the course of this deep dive. In this coming age of physical AI, is the company you are betting on?
Or even the company you work for.
Right. Are they the disruptor or are they the disrupted?
It is an existential question.
Yeah.
And to answer it, we have to look at what the source calls the holy trinity of AI success.
The Holy Trinity. Energy, data, and computing power.
Exactly. Because it's not just about having a smart chatbot anymore.
Okay, hold on. Before we get to the Trinity and why Tesla might be winning this new game, we have to look at the losers.
We have to understand the collapse of the software moat.
Right. Because for the last, 15 years, if you listened to any business analysis or read any investment blog, the advice was always the same. Buy B2B SaaS.
It was the golden goose. It was the undisputed holy grail of business models.
Why, though? For the listener who maybe isn't steeped in venture capital economics, what made it so untouchable? Why was everyone so obsessed with SaaS?
Okay, think about the traditional business model. B2B SaaS, which is business-to-business software as a service, was considered perfect because it lacked physical friction.
Okay, give me an example.
Let's say you want to build a chair. To sell your first chair, you buy wood, you hire a carpenter. To sell a second chair, you have to buy more wood, hire more carpenters, pay for shipping.
Your costs go up with every single sale.
Right, you have physical friction. But software, you write the code once.
That's your upfront cost.
Yes, and it's expensive, sure. You hire a bunch of software engineers. But once that code is written, you just click copy-paste a million times. The cost to service the next customer is basically zero.
The marginal cost is zero.
Virtually zero. You sell subscriptions to thousands of companies, so your margins are just insane, like 80–90% profit margins.
Unheard of in the physical world.
Completely unheard of. And the best part, once a company installs your software,
Oh, they never leave.
they hate switching. It's a massive pain. It's a nightmare to migrate all your company's data to a new system.
So you get locked in.
You get locked into their ecosystem, you pay your monthly fee, and the SaaS company just collects recurring revenue forever. You sleep, and the money comes in. It was literally a money printing machine.
It felt invincible. It was the safest bet you could make.
It felt invincible because there was a moat. And this is crucial to understand the source's argument. The moat was the complexity of the code itself.
Because coding is hard.
Very hard. It was incredibly hard to build a Salesforce. It was hard to build an Adobe. You needed armies of very expensive, highly trained engineers. You needed years of development time just to get a product off the ground.
That barrier to entry protected these companies from competition.
Exactly. If I wanted to compete with you, I needed $50 million in venture capital and 5 years just to get to the starting line.
But the source argues that this moat isn't just drying up, it's evaporating overnight.
It's gone. And it's gone because of AI coding agents. The source specifically points to things like ChatGPT, Copilot, and this new one, Devin.
Devin. I've seen the demos for Devin. It is honestly a little spooky.
It changes everything.
Because you don't just chat with it. It's not a search engine. You tell it what to do, and it goes off and acts like a senior software engineer. It plans the architecture, it writes the code, it executes it, it debugs its own mistakes.
Exactly. And that changes the fundamental economics of the entire tech industry. Let's play this scenario out based on the source.
Let's do it.
Previously, if you were an executive at a logistics company and you wanted a custom management program tailored for your specific trucking routes.
You have two choices.
Right. Choice A, you pay a company like Salesforce a fortune every year for a generic tool that kind of sort of fits your needs, but not really.
Or choice B, you hire an internal dev team for $500,000 a year to build a custom one.
Both are expensive, both are slow, but now there's choice C.
You just tell the AI to do it.
You literally tell an AI, build me a customer management program for my specific company. Make it track these specific routes. Make it look exactly like this. And the code is written in hours.
Sometimes seconds.
Right. So the scarcity of code is entirely gone.
Completely gone.
Code is becoming abundant. And in economics, when something becomes abundant, its price inevitably trends towards zero.
The source uses this incredible metaphor that really stuck with me. They say existing software companies are like sandcastles.
Sandcastles is a very fragile image.
It is, and I think that's exactly the point. They are beautiful. They're incredibly intricate. They took years to build. Investors look at them and say, wow, look at that structure.
But they're built on the sand.
They're built on the sand. And generative AI is a tsunami. The barrier to entry for creating software has dropped so low, it's essentially zero. So if I can generate your product for free...
Or if a scrappy startup can generate a clone of your flagship product over a weekend with 3 people and an AI agent.
Why on earth am I paying you a massive monthly subscription?
You aren't. And that is a terrifying reality if you're a software CEO right now. A tsunami washing away your beautiful sandcastle. It effectively means your core product is no longer special.
It's just a commodity. The key takeaway here, and this is really for you, the listener, especially if you're holding these stocks or working in this sector.
Pay attention to this part.
If your value proposition is just code on a screen, you are highly vulnerable because anyone can generate code on a screen now. The source argues the real revolution, the place where the actual value will be held going forward, isn't on the monitor anymore.
It's leaving the screen.
Which brings us to the second major section of our deep dive. Crossing the threshold from digital AI to physical AI.
Right.
You mentioned earlier that the digital brain needs hands and feet. Is that fundamentally how we are defining physical AI here?
That is the absolute simplest way to visualize it. Up until now, AI has basically been a brain in a jar.
A brain in a jar.
It lives in the cloud. It processes text. It processes images. It gives you a really good summary of a PDF.
Which is useful.
It's incredibly useful. It helps us write emails. It helps us plan trips. It helps us code. But physical AI is when that intelligence finally gains the ability to manipulate the physical world. It's the transition from summarizing a meeting
to actually making a cup of coffee.
Yes. Or building a car. Or folding your laundry. Or mining lithium in a dangerous cave.
It's interacting with atoms, not just bits.
Precisely. And the source points directly to the humanoid revolution to illustrate this. Specifically, Tesla's Optimus robot.
Right, Optimus. And I know, listeners have seen the videos on social media. Maybe they think it's a stunt. Maybe they think it's someone in a suit or CGI.
Other people dismiss it.
They do. But the source insists we have to stop thinking of these as sci-fi gimmicks and start looking at the balance sheet impact. The sheer economic impact of a viable humanoid robot fundamentally flips the structure of capitalism.
That is a massive statement. Flips the structure of capitalism. We really can't just gloss over that. How does it do that?
Well, think about labor. What is the single biggest line item on almost every company's profit and loss statement?
It's people. It's human labor.
Exactly. And human labor has hard limits. We need to sleep. We get tired. We get injured on the job. We have psychological needs.
We ask for raises. We form unions.
We have good days and bad days. And frankly, we don't like doing dangerous, repetitive, back-breaking tasks. We burn out.
But robots don't care. They work 24/7, 365 days a year. They don't complain about the cafeteria food. They don't need health insurance or a 401k.
But here is the real kicker that the source highlights, and this is the part that I think usually gets missed in the mainstream conversation: scalability.
Okay, explain that. Because humans scale too, right?
Hmm.
If I run a factory and I need more output, I just hire more people.
You can, but think about the training cost involved there. If you hire a new human worker, you have to train them from scratch. That takes time, it takes mentorship, there's a lot of trial and error, and everyone learns at a totally different pace. If you have 1,000 human workers, you essentially have to train all of them individually.
But if you have 1,000,000 robots,
They are connected, they share a brain.
they are networked. So if one of those robots in a factory in Berlin figures out a slightly better way to hold a wrench, or a more efficient way to fold a shirt, or a faster way to solder a circuit board,
You can just update the software over the air,
instantly.
and instantly all 1 million robots around the world know exactly how to hold that wrench better.
It's literally the Matrix moment.
I know Kung Fu.
Yes, I know Kung Fu, but for factory work, it creates this collective learning curve that humans just biologically cannot compete with. Humans have individual learning curves. Robots have a species-level learning curve.
So if you play this out over the next 10 years, what happens to the cost of doing things? If I'm building a house or manufacturing a car or assembling a phone,
The source argues that labor costs in manufacturing, logistics, and even dangerous jobs like mining or eventually space exploration could trend towards zero.
zero.
Effectively zero compared to what we pay now. You're basically just paying for the electricity to run them and some occasional maintenance.
The source emphasizes the absolute gravity of this. It's not just a minor efficiency improvement. It's
Right.
not like moving from a typewriter to a desktop computer. It is a total destruction and recreation of production methods.
If you can produce physical goods with near zero labor costs, the company that controls that labor force becomes the most powerful economic entity on Earth.
It sounds like the Industrial Revolution on steroids.
It is exactly that.
Huh.
It's the total decoupling of productivity from human physical effort.
Okay, I'm really seeing the board now. We have the collapse of the software guys because code is essentially becoming free.
Right.
We have the rise of the robots because labor might become free. But this is where the source gets very, very specific. It says, okay, everyone wants to do this. Google wants to do this. OpenAI wants to do this.
Meta wants to do this.
Right. But the source argues they can't, not like Tesla.
And this brings us to the Trinity.
The Trinity of AI dominance. This is the core analysis of the deep dive.
It really is the meat of the argument. If you take only one thing away from our discussion today, it should be this exact formula.
Lay it out for us.
AI success equals electrical energy plus data plus computing power.
It's a simple equation on the surface, but I get the feeling it's incredibly hard to actually solve in the real world.
Incredibly hard.
Hmm.
And the source argues that while big tech companies like Google, Microsoft, and Meta have some pieces of this puzzle, only Tesla has the perfect Trinity fully integrated.
Let's break these pillars down because I think a lot of people just assume big tech has us all covered. They have infinite money, right?
Money doesn't solve physics.
Good point. Let's start with pillar one, electrical energy. Why is this such a huge bottleneck? I mean, I plug my computer into the wall, it works. Why is energy suddenly a crisis for AI?
Because we aren't talking about plugging in a MacBook. We are talking about nation-state levels of electricity consumption.
Nation state levels.
Yes. Training these massive AI models consumes gigawatts of power. And that is just the training phase. Imagine running millions of robots globally. Imagine a fleet of millions of autonomous robotaxis. That's an entirely new, massive load on the power grid.
And the grid isn't exactly in great shape to begin with. We hear about brownouts in summer, aging infrastructure, lines going down in storms all the time.
The grid is creaking under its current load. The source points out that other big tech companies are literally hitting a brick wall right now. They're trying to build these massive new data centers, and the local utility companies are flat out telling them no.
They're saying, we can't give you the power.
They're saying, we can't supply that level of power for 5, maybe 10 years. We don't have the transformers. We don't have the generation capacity. The transmission lines can't handle it.
So they have the billions of dollars of computer chips sitting there, but they can't even turn them on.
Exactly. It's like buying a fleet of Ferraris and then realizing there are no gas stations anywhere in the state.
But look at Tesla. The source argues Tesla isn't just a car company anymore. They're a distributed energy utility.
They have the solution built entirely in-house.
They list 3 specific things here in the source: generation, storage, and distribution.
Let's look at generation first. Tesla is one of the biggest installers of solar panels and solar roofs in the world. They can physically generate their own power. Then you have storage, the Megapack.
Those are those giant shipping container-sized batteries, right? I've seen pictures of fields of them out in the desert.
Yes, exactly.
Yeah.
These are massive utility-scale battery storage systems. And why does that matter? Because the sun doesn't shine at night and the wind doesn't always blow.
Right, renewables are intermittent.
You need to buffer that energy. With Megapacks, you can store the solar energy generated during the day to run your data centers at night or when the main grid is unstable. You become your own backup power plant.
And then there's the distribution piece. This is the software piece the source calls AutoBidder.
AutoBidder.
It sounds like a Decepticon. What does AutoBidder actually do?
It's actually brilliant. It's an AI trading platform for electricity.
Real?
Yeah. Think of it like high-frequency trading on Wall Street, but instead of stocks, it's trading electrons. It allows Tesla to manage the grid efficiently. They buy power from the grid when it's cheap, store it in the Megapacks, and then they can either use it themselves or actually sell it back to the grid when prices spike.
So they're actively arbitraging electricity.
They are. The core analysis here is that Tesla has quietly built an independent end-to-end energy infrastructure, specifically to fuel its own AI ecosystem.
They don't have to wait in line at the utility company.
They don't have to wait for the local city council to approve a new transmission line. They can just do it. They're energy sovereign.
That is a massive strategic moat. If the grid goes down, or if industrial power just becomes too expensive, Tesla is completely insulated. Okay, so they have the power figured out. Let's move to pillar 2. And the source actually calls this one the moat. Real-world data.
This is perhaps the most controversial point in the research, and arguably the most important one to grasp. There is a massive distinction made in the source between text and physics.
Text versus physics. Break that down for me.
Okay, think about how an LLM like ChatGPT learns. It reads the internet.
Right.
It reads Reddit, Wikipedia, millions of books, New York Times articles. All of that is text. It learns how humans talk about the world. It learns symbols and associations.
So it knows that the word fire is associated with the word hot because it read a million sentences that said fire is hot.
Exactly. But it has never felt heat. The source argues that physical AI, meaning robots that have to operate in our world, needs to understand the actual world. It needs to implicitly understand space, geometry, and the actual laws of physics.
Meaning, knowing the dictionary definition of the word gravity isn't the same thing as catching a falling ball?
Exactly. You cannot learn gravity just by reading the word gravity on a screen. You can't learn the concept of friction by reading a Wikipedia page about friction.
You have to experience it.
You have to feel the slide on the ice.
Yeah.
You have to see how light reflects off a puddle at sunset and know it's a puddle, not a hole. You have to understand object permanence.
Like knowing that if a ball rolls behind a couch, it didn't just disappear from the universe.
Right, and you cannot scrape that kind of understanding from the internet. You can't just download reality from a server.
You need eyes in the real world.
I mean, sensors constantly interacting with the physical environment. And this is exactly where Tesla's massive fleet of cars comes in.
The cars are the eyes.
The cars are the eyes. Tesla has millions of cars driving globally every single day. And they are absolutely covered in cameras.
They are collecting video data constantly.
High definition, real-world video data. They are seeing snowstorms in Norway, torrential rain in Singapore, sudden aggressive pedestrians in New York City, unpredictable construction zones everywhere.
The edge cases.
Yes, the edge cases. The weird stuff that you can't program into a simulation. The plastic bag floating across the highway that looks exactly like a heavy rock to a radar system, but a visual camera system can learn, is harmless.
Or a construction worker holding a stop sign upside down.
Or a kid in a weird Halloween costume running into the street at dusk.
Things you just can't predict.
Exactly.
Like that.
The source describes this specific kind of video as physical data. It is the training manual for reality. And right now, it is arguably the most valuable resource on Earth, and Tesla effectively monopolizes it.
But wait, what about companies like Waymo or Cruise? Don't they have self-driving cars driving around collecting data right now? I see Waymos in San Francisco all the time.
They do. But the source makes a very sharp, very important distinction here. Waymo has a few thousand cars operating in heavily geofenced areas, highly mapped cities.
So they basically know every inch of those specific streets beforehand.
Right. It's a highly controlled environment. They rely on incredibly detailed, pre-mapped LiDAR data. Tesla, on the other hand, has millions of cars driving everywhere. Unmapped dirt roads, completely new suburban developments, highways in the rain.
The scale is just totally different.
The scale of data collection is orders of magnitude different. So while Meta is training its AI on our Facebook posts and our text,
Tesla is training its AI on the physical world itself.
on reality itself. And that is a moat that you simply cannot cross just by buying more hard drives or throwing more money at the problem. You need the fleet. You need the billions of physical miles driven.
You can't fake the miles.
You can't. Which leads us perfectly into pillar 3. Computing power.
Right, so you have the energy to run the system, you have the massive amounts of data to teach the system, now you need the brain to actually process all of it.
The hardware.
Now everyone buys NVIDIA GPUs, right? That's the gold standard.
Yes. Tesla buys them too. They buy tens of thousands of NVIDIA H100s, just like Microsoft and Meta do. But they realized that wasn't enough. They went a massive step further.
The Dojo supercomputer.
Dojo. This is fascinating from an engineering standpoint.
Sure.
Tesla realized that standard supercomputers, even the amazing ones from NVIDIA, weren't perfectly optimized for video data.
Because they were built for something else.
They were historically optimized for text or numbers. Large language models are text-based. But Tesla deals almost entirely in video.
And video is a massive amount of data compared to text.
It's incredibly heavy. So Tesla designed their own entirely custom supercomputer chip architecture, specifically to train its AI on video and visual data.
They built a custom brain to learn from their custom eyes.
Precisely.
That is just a crazy level of vertical integration when you step back and look at the whole picture. I mean, really think about it. They collect their own physical data with their own cars.
Yep.
They build their own custom supercomputer to process that specific data.
Right.
They generate their own solar energy to run the computer. And then they build the physical machine, whether it's the robot or the car, that actually uses the end result of all that processing.
It's a perfectly closed loop. It is the Apple model of vertical integration. But instead of applying it to a smartphone in your pocket, they're applying it to physical reality and heavy industry.
That has to be almost impossible to replicate.
It is. If a massive tech giant wanted to legitimately compete with Tesla on this exact front today, you wouldn't just need to build a smart robot.
You'd need a whole ecosystem.
You'd need to build a global car company just to get the data fleet. You need to build a solar and battery company to get the power grid. And you need to build a custom silicon chip company to process the video.
Good luck pitching that to your board of directors. That sounds like $1 trillion barrier to entry.
Exactly. That's the Trinity argument in a nutshell. That is precisely why the source believes Tesla is the destroyer in this scenario. They aren't just playing a better game. They're playing a completely different game on a board they built themselves.
So we've clearly established the infrastructure. We see this massive fortress they've built with power, data, and compute. Now let's talk about the actual product. Because section 4 of our deep dive is where the source drops the real aha moment for me.
The paradigm shift.
Yes. It says, essentially, do not look at Tesla as a car company.
Reframing the automobile entirely. This is a mental hurdle a lot of traditional investors have. They look at the road, they see a metal box with 4 wheels, and they think Ford or Toyota. They evaluate them on how many cars they sold this quarter.
But the source says a car is simply a robot on wheels.
Think about it. When you strip away the nice leather seats, the fancy cup holders, the air conditioning, and the branding, what actually is a self-driving car, mechanically speaking?
It's a battery, a motor, some cameras, and a computer.
It is a computer brain making real-time decisions based purely on visual input to navigate physical space, avoid dynamic obstacles, and reach a destination safely. That is the definition of a robot.
So now take the wheels off that robot and put legs on it.
And that is Optimus. That is the humanoid robot. The source explains the technical transfer here, and it's absolutely fascinating. The FSD, the full self-driving system, that is the brain.
Right.
The neural net that has been trained to successfully identify a faded lane line on a highway in a rainstorm is the exact same underlying system used by the Optimus robot to identify a coffee cup on a messy kitchen table.
Wait, it's just copy-paste?
Functionally, at its core, yes.
Yeah.
The mechanical process of see object, understand depth and geometry, predict its movement, and decide on an action, that loop is identical. Whether you are a car avoiding a swerving semi-truck at 70 miles per hour, or you are a robot hand picking up a tiny screw in a factory at 2 miles per hour.
The physics engine in the brain is the same.
Exactly.
So while all these other companies are in their labs trying to teach their prototype robots how to walk and see the world completely from scratch, Tesla is doing what?
Tesla is basically downloading a veteran driver into a walker's body.
That is a great way to put it.
They are transplanting a brain that has literally already experienced and navigated billions of miles of real-world chaos into a humanoid body. The source describes a very near future where this AI is just ported over.
Ported over like a software update.
Yes, these humanoid robots will enter the Tesla factories first to build the cars, then they'll be sold to logistics centers and warehouses, and eventually they will be in homes for domestic labor, folding laundry, cooking, cleaning.
And the massive implication here is speed. Because the brain is already being trained every single day on the roads by millions of cars, Tesla isn't starting at zero with these robots.
They are starting at mile 1 billion.
That is an insane head start.
That is why the source so confidently argues they will win this race. They have the training data. Look, you can build a robot body today. Honda has done it with Osimo. Boston Dynamics has done it. Those gymnastics robots doing backflips are mechanically amazing.
Right, the hardware is impressive.
But without a generalized brain that actually understands the chaotic, unpredictable physical world, it's just a really cool, really expensive toy that follows a pre-programmed script. Tesla has the generalized brain.
It's terrifying and incredibly exciting all at the exact same time. It really makes you realize that the car was never actually the end goal.
No.
The car was just the Trojan horse. It was the data collector to fund and train the general-purpose robot.
That is the ultimate long game. The consumer car business funded the massive data collection network required to build the humanoid robot.
Okay, so let's bring this all back to you, the listener. We have covered the tech, the energy crisis, the data moat, the compute. Now we hit Section 5. The investor's ultimatum. We started this whole deep dive with the idea of the destroyer versus the destroyed.
We have to return to that core premise, because this isn't just an interesting theoretical tech discussion. This is fundamentally about where global wealth and value will flow in the next decade.
The source argues that investing in traditional SaaS, those companies we talked about right at the beginning, the ones with the crashing red charts, is investing in the past.
It's investing in the sandcastle right before the tide comes in. It might look totally safe for another quarter, maybe even another year. They might still have great cash flow right now. But the structural foundation of their business model has been washed away by free AI code.
Because their core product, which is just code, is being completely commoditized by generative AI.
Right. But investing in the physical AI ecosystem, the companies mastering energy, data, compute, and robotics, that is investing in the future.
It's investing in the tsunami itself.
Exactly. Ride the wave. Don't build a wall against it.
The warning in the source material is pretty stark. It literally says, lightweight software technology cannot withstand the coming AI wave.
Lightweight, meaning easy to replicate. If 3 guys in a garage can use an AI agent like Devin to clone the core functionality of your software in a month, you do not have a moat. You are lightweight.
So what should investors look for?
The source says investors need to look for companies with deep, heavy physical roots, tangible, real-world assets.
You want to own the literal power plant.
You want to own the power generation. You want to own the massive data collection fleet driving on the roads. You want to own the physical factories building the robots.
You don't want to own the lightweight middleman software that connects them all, because an AI can just replace that middleman overnight.
That is exactly the paradigm shift.
Yeah.
We have spent 20 years in Silicon Valley being told software eats the world. It was the ultimate mantra.
Mark Andreessen's famous quote.
Right. Now, the new reality we were being told is physical AI eats software.
Software ate the world. Now physical AI is eating software. It's just the next link in the technological food chain.
It's pure evolution. The dominant species is changing.
Wow. So let's recap this journey before we let you go today. We covered a massive amount of ground
We
here.
really did. It was a marathon.
We started with the red charts of those crashing software stocks, the painful realization that the golden goose of the SaaS business model is dying because generative AI makes coding essentially free.
Then we moved to the definition of physical AI, the idea of digital brains finally getting hands and feet.
The economic earthquake of human labor, costs trending towards zero. The mind-blowing idea that networked robots scale physical knowledge instantly across millions of units.
We broke down the vital trinity: energy, data, and compute.
Yeah.
We looked at how Tesla is vertically integrated in a way that Google and Microsoft simply aren't, primarily because of their massive energy generation and unique physical data constraints.
And finally, the convergence. The realization that a self-driving car is just a robot on wheels, and the transition to humanoid robots is essentially just a massive software update away.
It really leaves us with a profound final provocation from the source.
It does. It's a question for you, the listener, to really mull over this week. And it is a heavy one. Is your portfolio, or frankly even your own career, based on things that can be easily generated by AI code? Or is it rooted deeply in the physical reality that AI is only just beginning to conquer?
It is a tough question. It's a fundamental question about where value lies. If I can type a text prompt into an AI and replace your daily output, you are in danger.
You are lightweight.
Yes.
Yeah.
But if your value requires interacting with the physical laws of the universe, manipulating energy, motion, or physical matter, you are the scarce asset.
And do you have one final thought on all this before we wrap up?
Just this.
Yeah.
If the source material is right about the timeline, if the cost to physical labor actually goes to zero, if robots eventually do the hard physical work of society, we have to ask a much bigger question. What is the fundamental value of human work? We are looking at a very near future where the basic definition of a job might change entirely. That's not just an investment question. That's a massive societal one. How do we find purpose if the robots can build the houses and farm the food for free?
A deep dive for another day, perhaps. But for now, the next time you see a Tesla driving down the road, don't look at it as just a car. Look at it as a scout, an invasion of the physical world that is just getting started.
It's a robot on wheels.
Thanks for joining us on the Deep Dive.
See you next time.